Yeah. So yesterday we talked about how uh, pH is a measure of concentration of one particular ion, which is basically H positive, and that's special because this is protons. So we just want to know how many protons are floating around in any particular solution at the moment. And based on that, we can figure out कि उसकी properties क्या होंगी, वो behave कैसा करेगा. And we talked about how acids and bases are simply substances that give or accept or donate or all of that, these protons. We also talked about how there's a mathematical function which is log, and that log basically talks about the powers. And because most of the time these are negative powers, so we take the minus log of how many protons you have. So based on that, we can easily figure out कि अच्छा वो चीज उसकी pH क्या है. So it easily allows us to compare the configuration of protons in any substance. We also talked about ionic product of water, and this is where we left off last night. That ionic product of water is basically the multiplication of the concentration of H positive and OH negative. Now, because it's an equilibrium, the only thing that can disturb this is any external influence or temperature. This is the only thing that can affect the Kw. Any external influence, Kw will try to maintain the balance. So Kw change nahi hoega. But what will it do is that it will try to shift the equilibrium so that the equilibrium comes back to the Kw. So all aqueous solutions will definitely have some concentration of H positive. And that we can show as acidity or alkalinity of that solution. So when I say that I have HCl of 0.1 mole per dm cube solution of HCl, then what I'm actually saying is that since HCl is a strong acid, this is a very important idea. It's a strong acid. Strong acid means that it ionizes fully, that all the molecules of HCl that are just dissolved, they will all give me the H positive that they can. So that means the concentration of this is equal to the concentration of H positive ion. And that will tell me that it is 0.1. So pH of this solution is simply going to be the first digit actually has the non-zero number. So it will be 1, or in other words, minus log of 0.1, which is again 1. And that's my pH. When I say that the pH, I have added, let's say 0.02 mole per dm cube NaOH, then what I'm actually saying is that because it's a strong alkali, okay, my assumption it's a strong alkali, that means it also ionizes fully, but this is not going to give me protons. It's actually going to give me hydroxide ions. These hydroxide ions are going to disturb the equilibrium that I have. So the concentration of hydroxide ions in here is 0.02. And this concentration, the 0.02 concentration, it's going to disturb the Kw that's already in there. So how much H positive concentration should there be for this OH minus to be accommodated by the water that we have? So let's look at that. In water, Kw is H positive and OH negative. Before I add hydroxide or sodium hydroxide, 1 out of 10 million water molecules is going to react, which means 1 times 10 power minus 7 is the concentration of H positive. And similarly, 1 into 10 power minus 7 is the concentration of OH negative. And that gives me Kw, which comes out to be 1 times 10 power minus 14. And the unit is mole squared dm minus 6. If I take minus log of this, that will be called minus log of Kw, will be called pKw. Or if I want to take just the pH, that will be minus log of H positive, and that will be minus log of 1 into 10 power minus 7. That will be just 7. Similarly, this one would be minus log of 1 into 10 power minus 14, which will be just 14. So we can say that the pKw is 14, or pH of water, neutral water, is 7. But now it's no longer neutral. What I've done is I've added this much hydroxide in there. But Kw तो उतना ही रहना चाहिए या pKw भी उतना ही रहना चाहिए. So I will try to figure out the pH of this solution using two methods. One is if I use the Kw value. Remember, temperature change नहीं होया तो Kw भी change नहीं होगा. So that means now Kw is still 1 into 10 power minus 14, but OH negative is not. Water was still providing 1 into 10 power minus 7 OH negative. But the moment you added this extra OH negative, which is way more than the OH negative coming from water, मतलब total OH negative कितना हो जाना चाहिए? It should be the OH negative coming from the base and the OH negative coming from water. But because the OH negative coming from water is really, really low compared to the OH minus coming from NaOH, this sodium hydroxide, we just ignore the value from water. Okay? And we focus on कि अच्छा water ने इस OH minus को match करने के लिए कितने H positive उसके पास अब रह गए होंगे. So this is basically going to be, so Kw is this, which is nothing but concentration of H positive now and concentration of OH negative now. So this is now going to be 1 into 10 power minus 14 equals H positive, which we do not know, times OH negative, which is basically 0.02. Why? Our assumption is that NaOH is a strong alkali, so the concentration of 0.02 will give me 0.02 OH. अगर ये weak alkali होती ना, तो I would have to figure out कि अच्छा 0.02 नहीं हुआ तो उसमें से कितना हुआ. But right now we're working with strong alkali. So now this gives me this. So I'll just solve this and X will come out to be 5 times 10 to the power minus 13. So this is telling me the H positive is this. So I will take the pH of this. So minus log of 5 into 10 power minus 13. And if you solve it, you can easily figure this out. So this will be 12.3. So clearly I have a very high pH, which is telling me that this is a highly alkaline solution. Now there's another way to figure this out. The Kw part is technically H positive times OH negative. And as I told you, log is like powers. So if the numbers multiply, powers add. So just like that, if I take minus log in here of this whole thing, then this will be minus log of H positive concentration multiplied with OH negative concentration. So आप देख सकते हो कि these are multiplying. So इनके logs add होंगे. So basically this will be written as minus log Kw is equal to minus log H positive concentration plus minus log OH negative. Now, this part is pKw. This part is pH. And this part is pOH. Now, I have this pOH here. It is minus log of the concentration. And pKw is always 14 at room temperature. So the pH is simply going to be minus log of 0.02, which is 1.69897. So ये इधर जाके minus हो जाएगा, and that will give me 12.3 as my pH. So I have two ways of figuring out the pH. One is कि मैं यहाँ पर concentration को लूँ. I first figure out the concentration of H positive, and using that, I figure out the minus log of that. That's one step. So मैं इसको लिख लेता हूँ that first you find concentration of H positive, and then you do minus log of that, and that gives you the pH. The other option is that I know the pKw of process. So pKw is 14, which is basically pH plus pOH. मैं pOH तो calculate कर लूंगा. So once I have that, I'll simply use this equation. So first calculate pOH, and then you do 14 is equal to pH plus pOH. And this is an interesting idea because all it's telling me is that अगर pH 1 होगी तो pOH 13 होगी. And that makes sense. pH 1 का मतलब है that I have a very, very high concentration of H positive, so a really, really low concentration of OH negative. And that is how I can easily figure out this whole process. So I'm going to give you a question now, and I want you to solve it. Now, Kw is any, just like any other constant, it will change depending on temperature. So let's say I have, uh, I want you to figure out the concentration of the pH of water at 60 degrees Celsius. And at that temperature, Kw is 2.6 times 10 power minus 14 mole squared dm minus 6. So go on, try to figure this out. You can use either of the two methods. So here's what you can do. Again, there are two ways to do this. One is you first figure out, Kw is this. So Kw is 2.6 times 10 power minus 14. And Kw is nothing but H positive times OH negative. Because there's no other source of OH minus or H positive. If H positive is X, then OH minus is also X. So that makes it X squared is equal to 2.6 times 10 power minus 14. And that will give me square root of this is going to be my answer. So square root of 2.6 times 10 power minus 14 is going to be my H positive concentration, which is a really low value, by the way. It is 1.61 into 10 power minus 7. So my pH is minus log of this, which is going to be 1.61 into 10 power minus 7. And minus log of this is going to be 6.79. Now, if you're like me, then आपके कैलकुलेटर में ना साइंटिफिक कैलकुलेटर्स में एक माइनस यहाँ पे होता है, एक तो इक्वल का साइन होता है ना, एक माइनस का साइन यहाँ पे होता है और एक माइनस साइन यहाँ पे भी होता है. सो जब हम जल्दी में कैलकुलेशन कर रहे होते हैं ना, तो अभी हमने ये कैलकुलेट किया है तो हम ये वाला माइनस प्रेस कर देते हैं, जिस वजह से कैलकुलेटर पता है क्या समझता है, वो कहता है अच्छा ये वैल्यू लो और इसमें से माइनस करो जो भी अगली बात बता रहे हैं. बट दैट्स नॉट व्हाट आई एम ट्राइंग टू से. आई एम एक्चुअली ट्राइंग टू से कि एक नई कैलकुलेशन लो बट उसको माइनस से मल्टीप्लाई करना है आपने. सो व्हेनेवर यू आर डूइंग दैट, मेक श्योर यू यूज दिस माइनस साइन इन योर कैलकुलेटर्स. Similarly, it is sometimes really tough to keep on writing 10. So there is one way of writing this. कि आप पहले 10 लिखते हो in your calculator, then you use this symbol, then you use minus 14. This is many different calculation और इसको लिखना मुश्किल होता है, फिर आप arrow दबाते हो and all of that. There is a button right next to equal sign. ये दो buttons, they are your friends. This button is multiply 10x, and this button is ans. पिछली कैलकुलेशन का आंसर आप यूज कर सकते हैं, and this simply tells you 10 to the power whatever. So अगर मुझे 1.61 into 10 power minus 7 करना है, तो I'll simply write 1.61 this button, and then I'll write minus 7. So मुझे वो एक ही बटन प्रेस करना है यहाँ पे, और वो सारा into 10 माइन पावर वाला सारा कुछ, it will take care of that. So these are a few things that I would suggest आप कैलकुलेटर यूज करते हुए ख्याल रखें जब भी आप कैलकुलेशंस कर रहे हैं. Okay. The other option that we had of figuring out कि अच्छा pH क्या होगी is कि अच्छा आपको पता है pKw is 14 and that is pH plus pOH. But right now your pKw is not 14. So pKw तो पहले आप कैलकुलेट करें ना. So that's going to be minus log of this answer. And then pH and pOH are the same. That means minus log of 2.6 times 10 power minus 14 is simply going to be pH plus pOH, यानी कि 2 times pH. क्योंकि दोनों सेम है तो सेम चीजें ऐड हो रही हैं. So that's what you will do. And if you do it, so आपका आंसर आएगा minus log of this thing 2.6 times 10 power minus 14, which is 13.585 divided by 2. So that is again 6.79. And that's my pH. So you have two different ways of figuring out what Kw is. A few things to remember. जब भी आप pKw निकाल रहे हैं at a different temperature, don't assume it to be 14. It is going to be something given to you using this. Minus log से calculate करें. ये कॉमन मिस्टेक है अगर आप इस मेथड से जा रहे हो. सिमिलरली इस मेथड से जब आप जा रहे हो, कॉमन मिस्टेक है कि आप ये लिखते हो और फिर कैलकुलेटर का वो माइनस का बटन दबाते हो, तो आपका आंसर सारा खराब हो जाता है. सो इसलिए make sure you use the right buttons and you make sure you use the right methods. Okay, so we can easily figure this out now. All right, so I'm going to give you one more question before we move on. So let's say I have 0 degrees Celsius now, freezing water. My Kw is 1.1 into 10 power minus 15. Can you quickly calculate the pH for this? So if you have done it correctly, then there are again two methods. One is I know that Kw is H positive times OH negative, and because there's no external source, these are both the same. So x squared is equal to 1.1 to 10 power minus 15. Take the square root, and the pH will simply be the minus log of this answer. So whatever answer I get, I'll take the minus log of that. So square root of 1.1 times square root of that हो गया. उसके बाद minus log of the answer gives me 7.48. Write it to three significant figures, and that's good enough. The other option is I know that minus log of this number, Kw, gives me 2 times the pH. Q, again, pH and pOH are the same. So I do minus log of this number. And then that is 14.9586. I divided by 2 to get my pH. So this will give me 7.48. So in both cases, I'm getting the same answer, which shows कि मैंने ठीक किया. Now, I want you to connect this to the previous question. In the previous question, the pH was 6.79 and the temperature was 60 degrees Celsius. In this question, the pH is 7.48. So if I am doing it right, then at 0, pH is 7.48. At 25 degrees Celsius, pH is 7. And at 60 degrees Celsius, the pH is 6.79. What is happening to the pH and what does it mean about water? So clearly we see pH is decreasing, which means water is becoming more acidic. Really? Is water becoming more acidic? Like if you say that things below 7 are acidic, then water is becoming more acidic. But that's not the case. Water can't be more acidic by itself because the H positive and OH minus are the same in pure water. तो फिर हो क्या रहा है? The idea that pH 7 is neutral comes from 25 degrees Celsius, room temperature. चीज किस pH पे neutral होती है? It depends on what the Kw of water is at that temperature. So जब आप 60 डिग्री की बात कर रहे हो तो at that temperature 6.79 से नीचे वाली चीजें एसिडिक हैं और इससे ऊपर वाली चीजें बेसिक हैं. 6.79 वाली चीजें न्यूट्रल है. Anything with a pH 7 at 60 degrees Celsius is not neutral. क्यों? क्योंकि न्यूट्रलिटी की जो डेफिनेशन है H पॉजिटिव और OH माइनस बराबर होने चाहिए, वो आयनिक प्रोडक्ट ऑफ वाटर जो है वही हमें 6.79 दे रहा है. So that means that 60 degrees Celsius 6.79 is what neutrality is. So the idea that pH 7 is neutral is basically tied to the 25 degrees Celsius. अगर टेम्परेचर चेंज होगा आपका pH स्केल चेंज होगा, आपका उसकी बेस पे न्यूट्रल या दूसरा कहना चेंज होगा. वन मोर आइडिया फॉर दिस इज कि जब भी आप इसको कैलकुलेट करो तो आपके पीछे एक assumption है जहन में कि my acid is completely ionized. But वो complete ionization can give you more than one H positive per molecule. So अगर मैं HCl की बात करूँ ना, so अगर मेरे पास HCl is 0.03 mole per dm cube, then my H positive is also going to be 0.03 mole per dm cube. But for the same concentration of H2SO4, this will change. Now, my H positive concentration is not this. It is 0.03 times 2 because every molecule of H2SO4 is giving me 2 H positives. This idea, this number, कि कितने H positive वो देता है, this is called basicity. That how many H positive is it providing per molecule? So the H positive concentration is simply going to be the concentration of the acid multiplied by its basicity. In the case of HCl, it was multiplied by 1, तो हमने कभी उसको explicitly solve नहीं किया है. But in the case of H2SO4, हमें वो करना पड़ेगा. But of course, we are again assuming, it's very important कि हमें अपनी assumptions का पता हो. We are assuming that H2SO4 is completely ionized. It doesn't have to be. There are cases जहां पर वो completely ionized नहीं होता. And this same idea will continue with alkalis. तो अगर मुझे NaOH को देखना है and I have 0.1 mole per dm cube of NaOH, then all I have to do is K OH minus concentration is going to be 0.1 times 1 because इसमें मुझे ये एक OH minus दे रहा है. But अगर मैं calcium hydroxide लूं and I assume, again, I'm assuming that calcium hydroxide is completely ionized, then the OH minus concentration is going to be 0.1 times this number 2, which is going to be my acidity of the base. Basically, कि OH minus कितने provide कर रही है ये base. So that is going to be times 2, which is 0.2 for the OH minus. And I will use that whenever I do calculations of pH or pOH. Now, this idea of ionization and the solution completely ionizing like this is limited to strong solutions, strong alkali, strong base, strong acid. This is closely related to that. अगर हमारी assumption कि वो 100% ionized नहीं हो रहा है, that is challenged, then we will have to come up with ways through which we solve that. And we will do that tomorrow. But for today, I'm going to use the remaining time to ask you to do a few questions for me. Okay, and I want you to try to solve them. And this time, I want you to tell me your answers as well. Okay. So first question is, calculate pH of 0.123 mole per dm cubed NaOH. Second is calculate pH of 0.136 mole per dm cube barium hydroxide. And number 3, calculate the pH if I have calcium hydroxide and all of that is dissolved with 2.78 grams in 1 dm cubed. So my assumption is that's completely dissolved. Go on, calculate your answer.